Welcome to mathsmaster.org. This lesson is Introduction to 2D Shape Properties. Which of these shapes is the odd one out, and why? Pause the video and give yourself a minute to decide which of these shapes is the odd one out, and it's important that you come up with a reason for deciding why. Maybe you said that this was the odd one out. This rectangle was the odd one out because it's the only shape there where all four angles in the shape are the same size. Maybe you said this was the odd one out because this rhombus here is the only shape where all four sides have the same length. On all the other quadrilaterals, all four sides are not the same length. Is this shape a trapezium? Well, yes it is. This shape is a trapezium. But what about this one? Is this shape a trapezium? Yes it is. What about this shape? Is this a trapezium? Yes it is. What about this shape? Is this a trapezium? Well, no it's not. And the reason that it's not has got to do with how many pairs of parallel lines there are. In this case there were one pair of parallel lines, but in this shape there are two pairs of parallel lines, and this shape is actually a parallelogram rather than a trapezium. So in the previous two examples we've been able to tell shapes apart and distinguish between shapes using their properties, and it's the properties of the shapes that allow us to tell different shapes apart. There are 5 main properties that we can describe about a shape. The first one is the side lengths. Are any of the side lengths on the shape the same, or are the edges the same length? Are opposite sides the same length, or are they sides next to each other that are the same length? We can describe a lot about a shape through describing its side lengths. The second shape property is the angles inside the shape, the interior angles. Are any of the angles the same? Are they all the same? Are angles that are opposite each other the same? And so on. We can describe lots about a shape using its angles. Are any of the sides on the shape parallel? That's another way of describing a shape. Do we have pairs of parallel sides? Do we have one pair, two pairs, or so on? Line symmetry is another way, the fourth way of describing a shape through its properties. Does the shape have any lines of symmetry? And finally, rotational symmetry. What order of rotational symmetry does the shape have? So let's have a look at how we can tell different shapes apart just by looking at the side lengths. Here I've got a rectangle and a square. If we look at the square, on the square all 4 sides have the same length. Whereas on a rectangle, the opposite sides to each other have the same length. There are 2 pairs of sides which have the same length. So you can see the top and the bottom side, which I've coloured in red on this rectangle, have the same length, and the green sides to the left and the right, those pair of sides have the same length. There are 2 pairs of sides that have the same length, and the difference between a rectangle and a square we can describe using the side lengths as we've just done. What's the difference between a rectangle and a parallelogram? Well, we can describe the difference using the shape properties, the angles in the shape. If we look at the rectangle, all 4 interior angles in that shape are all right angles. They're all the same. So all 4 angles inside a rectangle are the same size. Whereas if we look at the parallelogram, there's actually 2 pairs of angles that are the same, and they're the angles that are opposite each other that are the same size. So you can see here the 2 angles which I've coloured in blue are the same size, and the 2 angles which I've coloured in red are the same size, but obviously the blue angles and the red angles are a different size. So in a rectangle we had all 4 angles the same size, whereas in a parallelogram you have 2 pairs of opposite angles which are the same size. What's the difference between a trapezium and a parallelogram? Well, we can describe that difference by looking at how many parallel sides the shapes have. So in a trapezium, there's just one pair of parallel sides. What we mean by that, of course, parallel means that if you extended the sides on forever, they'd never cross. So if you stretch the sides in the same direction, in both directions on forever, they're like train tracks, if you like. They never cross each other. That's what we mean by parallel sides. So in this trapezium, the side at the top and the bottom are parallel, because if we stretch them on forever in both directions, they would never cross each other. Another way of thinking is that they're pointing in the same direction, if you like. So there's one pair of parallel sides in a trapezium, but in a parallelogram, there's 2 pairs of parallel sides. So the top and bottom side, which I've drawn this red arrows on here, are parallel to each other, but then so are the the sides on the left and the right, which I've shown in blue. They're parallel to each other, they point in the same direction. And note that we normally draw arrows on the sides like this to show where pairs of sides are parallel. So we've described the difference between a trapezium and a parallelogram by looking at which sides are parallel and how many sides, how many pairs of sides are parallel. What's the difference between a kite and a rhombus? Well, one way of describing the difference is by looking at how many lines of symmetry the shapes have. So if we look at the kite, it just has one line of symmetry. Imagine if you put a mirror on that blue dotted line and you looked at that shape, the reflection that you'd see in the mirror would be exactly what is drawn on the page there. So that's a line of symmetry, and a kite has just one line of symmetry, as you can see here. A rhombus has 2 lines of symmetry, and I've drawn them on in blue and red, as you can see here. Again, if you put a mirror on either of those 2 lines, the reflection that you would see would be what's actually drawn on the page here. So one way of describing the difference between a kite and a rhombus is by looking at the shape properties that are the numbers of lines of symmetry that the shapes have. We could describe the difference between an equilateral triangle and an isosceles triangle by looking at the order of rotational symmetry that the shapes have. That just means how many times can you turn the shape so that it looks exactly like it does in the original position. So for example, with the equilateral triangle, we could turn it a third of a turn. So we could turn it a third of a turn and it would look exactly the same as it did when we started. We could also turn it another third of a turn and it would look exactly the same. And we could turn it another third of the turn and it looks exactly the same, and we'd be back to where we started. So an equilateral triangle has rotational symmetry of order 3 because we could turn it 3 times to get back to where we started, and each time that we turned it, it looked exactly the same. Okay. An isosceles triangle has no rotational symmetry at all. We can turn it, but it's not until we've done one whole turn that we get back to where we started. So an equilateral triangle has a rotational symmetry of 3, of order 3, whereas an isosceles triangle has no rotational symmetry at all. So we can tell the difference between the two shapes by describing the rotational symmetry that they have. So just to recap, shape properties allow us to describe shapes and the differences between shapes. The question might come up, how do you know this shape is a kite rather than a rhombus? And you would be able to say, well, I know this because the side lengths of the kite are two pairs of sides that have the same length, whereas on a rhombus there are four sides which all have the same length. So both shapes both have four sides, but on a kite there's two pairs of sides which have the same length, whereas on a rhombus all four sides are the same length. So we can use shape properties to describe differences between a shape and also to describe how we know a shape has a certain name. And there's 5 different ways really that you can describe a shape's properties. They are the side lengths, the angles, the parallel sides, the line symmetry, and the rotational symmetry. That was Introduction to 2D Shape Properties. If you want to see some more great maths videos, please visit mathsmaster.org.